Good morning, students. Children, today we will be studying about the acids and bases. Acid, bases and salts, chapter number 5 from Science and Technology, part 1. Before we proceed towards the chapters, let us have a short recapitulation regarding the ionic compounds. Which compounds are known as the ionic compounds? So children, you should know that the molecule of an ionic compound has two constituents, namely cations, that is the positive ion or basic radical, and the next one is anion, that is the negative ion or the acidic radical. Children, you should know that there is a force of attraction between these ions and they are oppositely charged and they are called as the ionic bond. The force of attraction between one positive charge on a cation and one negative charge on an anion makes one ionic bond. Now what happens during the dissociation of the ionic compounds? On dissolving in water, an ionic compound forms an aqueous solution. In the solid state, the oppositely charged ions of the ionic compounds are sitting side by side. But when the ionic compound begins to dissolve in the water molecules push themselves between the ions of the compound and separate them from each other. This is to say that an ionic compound dissociates while forming an aqueous solution. Okay children, now this was regarding the ionic bond and ionic compounds. Now we will be studying about the chapter in the upcoming videos. Children, now we will be focusing about studying the concept about the Arrhenius theory of acids and bases. A Swedish scientist, Arrhenius, put forth the theory of acids and bases in the year 1887. The theory gives the definition of acids and bases as follows. So according to the Arrhenius theory, the acid is a substance which dissolving in water gives rise to H plus ions as the only cation. Okay, so acids are the substance which give only H plus ions. So for examples of the acids are HCl, that is the hydrochloric acid, H2SO4, sulfuric acid. Children, if you will see this, you will be coming to know that these gives rise to H plus ions, means the acids are the substances which are having the hydrogen as a positive and H2CO3, carbonic acid. Okay children, so this is example of the acids. So more acids you can go, nitric acids are there, sulfuric acids is there, hydrochloric acids are there. Different types of acids are having H plus ions as the only cation. Now when you dissociate, when these acids break, okay, dissociation means what we have studied in the previous video. Okay, so when HCl dissociates, it gives which ion? Hydrogen as positive ion. So here you will be able to see now H plus Cl minus. Then in H2SO4 you get H plus and HSO4 minus. Again, if you minus HSO4 into two parts, you will be again getting hydrogen plus and SO4 minus. So children, this is how the acids are formed. Okay, this is how the acids are formed, and hence we are saying that the acids are the substance which give rise to H plus ion. Now if you go and see the concept of the base, a base is a substance which on dissolving on water gives rise to OH minus ion as the only anion. For example, NaOH, CaOH2. Now when you will study about the NaOH, that is sodium hydroxide, here you will come to know. Now you just look towards the equations given over there, the concept will become more clear. NaOH, so when you dissolve NaOH in water, sodium hydroxide, you get Na plus and OH minus. Okay, so here your OH minus is negative, then CaOH2, Ca2 plus and OH minus. Just compare here. Here it is given, it gives rise to OH minus ion as the only anion, and that is known as a base. Okay, so here children, in this video we have studied about the concept about the acid and the base. I want to tell you children, please read the textbook, go through both the videos twice or thrice, so your concept will be clear regarding the acids and the bases. And then after this we will be continuing with the chapter further. Till that children, please read the textbook and watch the videos. Good morning children. Children, now we will be studying the concept of classification of acids and bases. So children, first we have to study about the strong and weak acid, strong and weak bases, and strong and weak alkali. Now strong acids are the acids which on dissolving in water, mostly they are giving you the certain components like which are more in the H plus ion and very small acidic radical. So examples of which H plus ions are in more quantity in strong acid. So examples of strong acid are hydrochloric acid, hydrobromic acid, nitric acid, and the sulfuric acid. Then children, we are having the weak acid. So children, weak acid is the acid which dissolved in water, does not dissociates completely, and aqueous solution contains H plus ion in small proportion and large proportion of the undissociated molecules of the acid. So examples of the weak acid are the carbonic acid and the acetic acid. Carbonic acid H2CO3 and acetic acid CH3COOH. Then children, we are having the strong base. Children, strong base is the base which on dissolving in water completely gives aqueous solution, mainly OH minus and the concerned basic radicals. So example of the small strong base are sodium hydroxide, potassium hydroxide, calcium hydroxide. And weak base. Children, weak base is the weak base which does not dissociate completely and resulting aqueous solution contains a small proportion of OH minus ion, whereas large proportion of the undissociated molecules of the base. So example of the weak base is NH4OH, that is the ammonium hydroxide. So now you can say that ammonium hydroxide is a weak base. Now children, along with the alkali. So alkali are the bases which are highly soluble in water. Children, this if you want you can underline that alkalis are the bases which are highly soluble in water. Now, so these alkalis are also different types. Now examples of alkali are sodium hydroxide, potassium hydroxide, and ammonia. Now here you will be able to see that NaOH, sodium hydroxide, and potassium hydroxide are the strong alkali, where ammonia is the weak alkali. So children, here we have studied about the concept of the strong and weak acids and strong and weak bases and strong and weak alkali. Now children, I request you all that it's once again goes through the videos from the previous first videos which we have seen for this chapter. Read the lesson, so your concepts will be becoming more and more clear as the time goes. Okay children, remaining we will be looking into the upcoming videos. Students, now we will be studying about the concepts of the basicity and acidity. What is the basicity and what is the acidity? Acids and bases are also classified according to their basicity and acidity respectively. Basicity of the acids, the number of H plus ions obtained by the dissociation of one molecule of an acid is called its basicity. Whereas the acidity of the bases means what? Acidity of the bases revolves around the concept that how many OH minus ions you are getting on dissociation of one molecule of the base. It is known as the acidity. So see children, this is something I want you all to focus on the concept, read the lesson, watch the videos twice, so your concepts will become more clear. Okay, so here we have completed the concept about the basicity. Okay, once again I will be repeating. See, the number of the H plus ions which are obtained when the one molecule dissociation, I think so we have studied previously also. So this is nothing new for you as per my concept, but okay, if any queries are there, so you can read the lesson and watch the videos. So basicity means, and acidity means what? How much number of OH minus ions are obtained on the dissociation of one molecule of base. So this is about the regarding the concepts of the basicity and the acidity. Remaining we will be looking into the upcoming videos. Students, hope you all are fine. Today we will be proceeding towards the next concept. We will be studying today the concept of concentration of acid and base. Now this is the activity given in your textbook. What you have to do, you have to cut the two equal parts of the lemon. Take the juice in each part in two separate beakers. You have to put 10 ml of drinking water in 1 ml and 20 ml of drinking water in another ml. You have to stir the solutions in both the beakers and taste them. Do you find any difference in the taste of the solutions? You have to notice that. And then what is the difference? Okay, so if you will go through the above activity, if you are going to perform this activity, you will be coming to know that the sour taste of the solution is due to the lime juice. Okay, but the quantity of lime juice is same in both the solution. Then also the taste is different. And why the taste is different? The beaker which is having less water is tasting more sour than the one which is having more water. What is the reason behind that? Although the quantity of the solute is same in both the solutions, the quantity of solvent is different. Students, the ratio of the quantity of solute to the quantity of the resulting solution is different, and due to this the ratio is larger for the solution in the first beaker, and therefore that solution tastes more sour. On the other hand, when the lemon juice in the second beaker is the total solution, the proportion of lemon juice in the total solution is the smaller, and the taste is little sour as compared to the previous one. So with this activity we understand that even though the lemon juice is same, but the quantity of the solvent is different, and that is defining the taste of the lemon juice or taste of the juice which you are making, and that is depending upon this is known as the concept of the concentration. Now the proportion of a solute in a solution is called concentration of the solute in the solution. Okay, so proportion of the solute in a solution is known as a concentration of solute. When the concentration of solute in its solution is high, when the solute is more, you can say when the concentration of solute is high, the solution is said to be concentrated, and when the solution is less, then it is known as a diluted solution. Okay, so when the concentration of solute is less, it is known as a diluted solution. So this was regarding the concept we have studied about the proportion. How is the proportion of solute and solvent affecting the taste of the lemon juice which you are consuming. Okay, now children, just if it is possible for you, please try this activity at home. Okay, they have suggested you to take the beakers. Since the beakers are not available at home, better you can take a glass. Okay, any glass, made of glass, or any utensils which is available at your home, you can take in a small cup also if you want. So the quantity and ratio will be remaining same. And if you once you try this experiment, you yourself will be able to understand the concept very clearly regarding the proportion of the solute and how it is affecting the concentration, is affecting the taste of the total solution. Okay, now other things which are related to this chapter we will be looking forward. And please read the lesson, please read the textbook, watch the videos twice or thrice, so your concepts will be becoming more clear. Children, now we will be continuing with the concentration of acid and base. Several units are used to express the concentration of solution. Two of these units are used more frequently. The first unit is the mass of solute in grams dissolved in 1 liter of solution. It is known as gram per liter and expressed in the short form small g upon capital L. So G stands for gram and capital L stands for the liter. Okay, so this is the one of the method in which we are expressing the unit of the solution, concentration. Then the next unit is the number of moles of the solute dissolved in 1 liter of the solution. So this mole you have already studied in the matter. Okay, measurement of matter, 4th chapter you have already studied. The concept of moles is very clear to you now. So the second unit is the number of moles of the solute dissolved in 1 liter of the solution, and this is also called the molarity, M of the solution. Molarity M of the solution. The molarity of a solute is indicated by writing its formula inside a square bracket. For example, NaCl1. So means the molarity of the solution of common salt is 1m, and 1m is pronounced or it is said as 1 molar. When you are writing 1m, it indicates that you are saying it is 1 molar. Now see children, there is one table given in your textbook. Okay, and you have to solve that table. It is given in your textbook. Now see, this is the table. Okay, so here what I am just going to explain you, I am going to explain you the certain gaps which are here we have to fill up. So first is given to you, first one they have done for you. The first name of the first substance is sodium chloride, that is NaCl. Molecular formula NaCl you know. Molecular mass is 58.5 units. So quantity of solute. Okay, so suppose if you are having 170 grams, okay, then how many moles it will be? So it will be 2 moles. Okay, and volume of the solution, suppose it is 2 liters, then what will be the concentration of solution? It will be 58.5 gram per liter. It is equivalent to 1 mole. Now second substance is given to you as HCl. HCl means what? Yes, hydrochloric acid. Now this is the solution table I have given to you. On basis of this solution table, you have to complete this table given in your textbook. Okay, so I will be sharing the solution answers also. So HCl means what? Hydrochloric acid. Now the molecular mass of hydrochloric acid, it is 36.5 units. Okay, now quantity of solute, suppose quantity of solute, how much it is given? It is already given, 3.65 grams. Okay, now how much mole solution it is becoming? It is becoming, yes, 36.5 divided by 3.65, it is 0.1 mole. Okay, it is already given there. So this answer table also I am sharing with you simultaneously. The bold part which is there, the bold words adding, those are your answers. It is becoming 0.1 molar solution. So molecular mass divided by gram, so that gives you the quantity of the mole. It is 0.1 mole. And volume of the solution, how many liters? It is in 1 liter. So the concentration of the solution is going to become 3.65 gram per liter. This much quantity is making your 0.1 molar solution. Okay, then the next is NaOH, means sodium hydroxide. Okay, so molecular mass of sodium oxide is NaOH is not given, but we are aware it is 40 units. Okay, so 40, and how much grams of it is? It is 60. So 40 divided by 60. Okay, if you divide 60 by 40, you will be getting the answer 1.5 mole. And the volume of solution given, volume of solution already given in 2 liters of solution, you have to make it. So volume of solution is 2 liters. So the concentration of the solution will be becoming 30 gram per liter. It is going to be equivalent to 0.5 0.75 moles. Okay, it is going to become the 0.75 moles per liter. So this is regarding the solution of the table. Complete this table in your textbook. Okay, so your concept will be becoming more clear. Good morning, students. Children, today we will be studying about the concept of the pH of the solutions. Okay, so how to calculate what is the pH, what are the different pH ranges. We are going to study these things in today's session. Now see, we have seen that acid and bases dissociates to a smaller or larger extent on dissolving in water to form H plus and OH minus ions respectively. These H plus and OH ions are found in different proportions in all natural aqueous solution, and that determines the properties of those solutions. For example, the proportion of H plus and OH minus ion divides soil into acidic, neutral and basic type of soils. So children, now see, you should know that there are different ranges. Okay, acidic soil is different, basic soil and the neutral soil. Now how we will understand whether the soil is acidic or basic? It will be recognized with the help of the aqueous solution of the soil. If you form an aqueous solution, then with the help of many different indicators, pH paper, you will be able to know whether the soil is acidic, basic or the neutral. Even though it is necessary for blood cells have etc. to have H plus and OH minus ions in a certain definite proportions for their proper functioning. Now children, fermentation. Regarding fermentation, you have studied in the chapter useful and harmful microbes. So now till now you are very well aware with the term of the fermentation. Now children, this fermentation is carried out with the help of the microorganisms, other biochemical processes, and also many chemical processes also require the proper proportion of H plus and OH minus ion to be maintained within the certain limits. So these fermentation process, other biological chemical processes, they require the certain pH, and at that definite pH only those processes will be taking place very actively. Even the pure water also undergoes dissociation to a very small extent and gives rise to H plus and OH minus ions in the aqueous solution. So children, till here we have studied about the importance of the pH. Okay, now see, this is the table. It is given in your textbook. Now in this table the pH of the different solutions are given. Now see children, if you see the pH range, the range of the pH, it is right from 0 to 14. Okay, so now in upcoming videos we will be studying in detail about the pH range, pH scale and the different substances and and their pH. Good morning students. Now children, here we will be again continuing with the previous, in the coordination with the previous video, we will be studying the concept about the pH solution. Now see, this is the table. It indicates the pH of the different substances at different, okay, and their ranges. Okay, now see children, if you will be looking to the table very keenly, you will come to know that the pH from 0 to 7, okay, the substance who is having pH as 0 is strong acid, while the substances having pH 14 are the strong bases. Then from 0 to 7 the range is approximately acidic, and after that onwards the range goes for the basic substance till 14. Now in year 1909, the Danish scientist Sorensen, he introduced a convenient new scale of expressing H plus ion concentration, which is found to be very useful in chemical and biochemical process. And that procedure today we are calling it as pH scale, and pH is known as the power of hydrogen. pH is the short form of power of hydrogen. The pH scale extends from 0 to 14. According to this scale, the pure water has pH of 7. It means pure water has H plus is equal to 1 into 10 raised to minus 7 mole per liter. The pH 7 indicates the neutral solution. The solution is neutral. Neither it is acidic, neither it is basic. So this pH 7 is the midpoint of the scale. Now, the pH of an acidic solution is less than 7 and pH of the basic solutions are the greater than 7. This we have already studied. Now, we will go through the video once again. We'll go to the first slide and here we will be discussing the pH of certain substances. Now see, gastric juice, its pH is 1. Lemon juice, very common, okay. So lemon juice, its pH is 2.5. Vinegar, its pH is 3. Tomato juice, its pH is 4.5. Black coffee, 5. Acid rain, its pH is 5.6. Urine, 6. Rain, milk, the pH is 6.5. Now pure water, sugar solution, their pH is 7.0. And the blood, okay, now you will come to know blood is mildly little base, okay, alkaline. So that's why its blood pH is 7.4, okay, near about to neutral but 7.4. Solution of baking soda, its pH is 8.5. Toothpaste, okay. So now you are aware that your toothpaste is basic in nature. So your toothpaste pH is 9.5. Milk of magnesia 10.5. Lime water, okay. So when you are dissolving lemon in water, okay, lime water, its pH is 11.0. And sodium hydroxide, 1 molar sodium hydroxide, its pH is 14. So children, till now we have studied about the pH, concept of pH, okay. Then which substances are known as acidic and which substances are known as basic and which substances are known as alkaline. Now acids means the substance range 0 to 7 and above 7 it is neutral and 7 is the, you can say, above 7 it is basic, 7 is neutral and below that is the acidic, okay. So this is the pH range of the different substances. Now in upcoming videos we will be studying about the another remaining concepts of your chapter. Good morning students. Now children, here in this videos we will be studying about the universal indicators. Before I start with this point, let us make certain things clear. What are the universal indicators? Now children, you have studied about the pH. Yes, you are aware of the pH range. But how do we actually recognize the pH? How we determine the pH? How you will come to know that this is a substance is acidic and this is basic? There should be a certain system, no? There should be certain indicator. There should be certain method to determine the pH. So here we are going to study about those certain things which help us to determine the pH. So we know that some natural and synthetic dyes show two different colors in acidic and basic solutions. Such dyes are used as an acid-base indicator. In the pH scale, the pH of solution varies from 0 to 14 in accordance with the strength of the acid or the base. Now, to show these variations in pH, a universal indicator is used. So, now if you want to study the pH of a substance, a universal indicator is used. And a universal indicator, what is its function? It shows different colors at different values of pH. Now see children, this is the first diagram. If you will see where 1 to 14 numbers are given, this is a, yes, what is this? Yes, this is a litmus paper. You are very well aware of this, okay. So now here there are the different instruments given. See here you are able to see the pH meters also. Then The litmus paper is also shown. So it is indicating the pH range. Okay, so 7 is the natural, below 7 the solutions are acidic, and above 7 the solutions are basic. Then again you are able to see the pH indicator also. So now these indicators, these pH meters, universal indicators, these are the substances which when we use help us to determine the pH of the substance. Now how is the universal indicator made? It is made by mixing several synthetic indicators in a specific proportion. The pH of a solution can be determined by means of a universal indicator solution or the pH paper made from it. Okay, so either you can use the universal indicator solution as given below. Okay, see the test tubes which are showing different ranges of pH, or you can use the pH paper. But is this the standard method? Many times there may be certain errors. So the most accurate method of measuring the pH of a solution is to use an electrical instrument called pH meter. In this method, pH is measured by dipping electrodes into the solution. See, I'll show you. See, our instrument is shown here and a pink color beaker is there. So now this instrument is known as a pH meter, and when we want to measure the pH, pH is measured by dipping the electrodes into the solution, and whatever the value of pH, it is indicated. See here, it is indicated 11.99. Okay, so this means this substance is basic in nature and the pH comes very accurate. So here we have studied about the different indicators which help us to determine the pH of the various substances. Okay, children. So children, go through the videos, read the textbooks, read the lesson, and try to find out the pH of different substances which you use in your home. So that you will also feel very interesting to know the pH of the different substances. And read the lesson, revise the videos. Good morning, students. Children, now we will be proceeding towards the section. We will be studying about the reactivity of acids and bases. So this is a new concept. What is neutralization? Other things you will be studying, but once you want to understand what is neutralization, you should know that in the neutralization reaction, an acid reacts with base to form salt and water. Okay, so now in the upcoming slides we will be studying about the neutralization reactions. Now see what happens in the neutralization. Children, you have to take 10 ml of dilute HCl. Okay, this is some activity, so just we have to observe this activity using glass rod and put a drop of this solution on a pH paper and record the pH of the solution. Then after some time you have to take a few drops of sodium hydroxide by means of dropper, stir the solution with the glass rod and then measure the pH of the paper. Okay, then what we have to do, measure the pH resulting solution by putting drop of its solution on the pH paper. In this manner, go on adding NaOH, okay, and record the pH. What are we going to find? That will be the out product. So what you will be coming to know that pH, why does the pH of the NaOH solution is increasing? Okay, so why does it increases? The answer lies in the process of dissociation. What happens? See here, children. Both HCl and NaOH dissociate in their aqueous solution. Addition of NaOH solution to HCl solution is like adding larger concentration of OH ions to larger concentration of H plus ion. However, water dissociates H plus and OH minus ions to a very small extent. Therefore, the mixing of excess OH minus combines with excess H plus to form H2O molecules which mix with the solvent water. And this can be represented by ionic equation as H plus Cl minus plus Na plus OH minus gives Na plus Cl minus plus H2O. And this can be seen in the above reaction that Na plus and Cl minus ions are on the both sides, and therefore the net reaction is H plus OH minus gives H2O. Okay, so as the NaOH solution is added by drop the HCl solution, the concentration of H plus ion goes on decreasing due to combination with OH minus ion, and this is how the pH is going on increasing. So when enough of NaOH is added to HCl solution, the resulting aqueous solution contains only N plus and Cl minus ions, that is NaCl, a salt, and the solvent is the water. Then only the H plus and OH minus ions in the solution is dissociation of water, and therefore this reaction is called as the neutralization reaction, and it can be represented as HCl plus NaOH gives NaCl plus H2O. Now children, this is the table given in your textbook. Okay, so we have to complete this table. So here I have given you the answer table. Okay, please complete this answer table in your science textbook itself. Okay, I'm giving you few minutes so that you can write down. See, this table is given that acid plus base gives salt and water. Here different acids are given. Now here HNO3 is given. So which base you will have to add? You have to add here KOH, because you are getting the potassium nitrate KNO3. Okay, so this I am keeping for few minutes. Kindly complete this. Okay, remaining part we will be going to study in the upcoming videos. Good morning students. Now we will be studying here the reaction of acids with the metals. Now the reaction of acid with metals is determined by the strength of the concentration of acid and also by the reactivity of the metal and the temperature. It is easy to bring about the reaction of a diluted solution of strong acids with moderately reactive metals at a normal temperature. Now consider if a magnesium metal reacts with dilute hydrochloric acid and an inflammable gas, hydrogen gas, is formed. During this reaction, the reactive metal displaces hydrogen and to form acid to release to the hydrogen gas. At the same time, the metal is converted into basic radical, which combines with the acidic radical to form the acid to form the acid and the salt. What happens when acids react with oxides of metals? So for this, if you take some water in a test tube and add a little red oxide, okay, to it, now add small quantity of HCl to it and shake the test tube. Now the chemical formula of ferric oxide is Fe2O3. The water insoluble red oxide reacts with HCl to produce water soluble salt FeCl3. This gives a yellowish color to the water, and the following chemical equation can be written for the chemical change. That is Fe2O3 plus 6HCl gives twice FeCl3 plus thrice H2O. So this is how the reactions are written. Now see children, we have studied the effect of different products. Okay, first we have studied what happens when acids react with metals. Then what happens when reaction of acid with oxides of metal takes place. Okay children, I request you all to watch the videos twice, to please read the textbook, so whatever queries are there, that can be understood and it can be solved by self-study also. Okay, please read the read the textbook and go through the videos. Good morning children. Children, in Science and Technology Part 1, your 5th chapter, Acid, Bases and Salts. Now we are going to focus towards the concepts of reaction of bases with oxides of non-metals. Means children, when the oxides of non-metals react with the bases, okay, what type of end product you are going to get in the products. Okay, now see. Now what happens children, bases react with oxides of non-metals to form a salt and water. So your output will be salt and water. Hence, oxides of non-metals are said to be acidic in nature. Sometimes the oxides of non-metals themselves are said to be examples of acids. Now, zinc oxides reacts with sodium hydroxide to form sodium zincate and water. Similarly, aluminium oxide reacts with sodium hydroxide to form sodium aluminate and water. Then the next reaction we are going to study about the reaction of acids with carbonates and bicarbonates of metals. Means what happens when any acid reacts with carbonates and bicarbonates of the metals. So children, for this we have to just overlook an activity. Fit a bend tube and a rubber cork. We have to take certain lime water in a test tube. Then we have to take baking soda in another test tube and add lemon juice. Okay. Immediately we have to fit the bent tube over it and insert to its other end to the lime water. Then we have to note down the observation in both the test tubes, and we have to repeat the procedure using washing soda, vinegar and HCl properly. So in this activity, when lime water comes in contact with the gas released in the form of effervescence, it turns milky. So which is this chemical test? This chemical test is for the carbon dioxide gas. So when lime water turns milky, we infer that the effervescence is of carbon dioxide gas, and this gas is produced on reaction of acids with carbonates and bicarbonate salt of metals. A precipitate of CaCO3 is produced on reaction with the lime water, and this reaction can be represented by the following chemical equation. Okay, so chemical is given below that. When CaOH2 reacts with carbon dioxide, you get CaCO3 plus H2O. So you can see that when calcium hydroxide reacts with carbon dioxide, you get calcium carbonate and sodium and water. Okay, you get CaCO3, calcium carbonate and the water. So children, this was regarding the reaction of the acids with carbonates and bicarbonates of the metals. Now after this we are going to study about the next concepts in the upcoming video. Children, please watch the video and read the lesson, so whatever concepts your teacher is teaching, it is becoming more clear to you, and you will be also having the practice of the lesson, and you will get a good chance to revise also. Good morning students. Children, now we will be studying about the salts. What are the different types of salts? Okay, so the types of salts are acidic salt, basic salt and the neutral salt. Children, we should know that an acidic salt is formed by the neutralization reaction between strong acid and a weak base. When a strong acid reacts with the weak base, we get the acidic salt, and the pH of aqueous solution of acidic salt is less than 7. On the contrary, a basic salt is formed by a neutralization reaction between weak acid and a strong base. The pH of an aqueous solution of such basic salt is greater than 7. Along with that, children, we have to study the concept of water of crystallization. For this, certain activity is just mentioned over here. We are going to overlook this activity. We are going to go through it just in short, so you will be understanding the concept of the crystallization very properly. So it is mentioned that we have to take some crystals of blue vitriol in 2 test tubes, add some water in 1 test tube and shake it. So we have to see what color comes, okay, and what color of the solution is formed. On the another hand, on low flame we have to take the another test tube and we will have to see what change occurs in the color. So after some time we will come to know that on heating the crystalline structure of the blue vitriol breaks down to form colorless powder and the water came out. Okay, so when we are heating it, children, this activity is given in the textbook also, so you can refer for the procedure in the textbook also in much more detail. Now what happened when we heat the blue vitriol, its structure breaks out and the colorless powder is formed and the water comes out. This water was a part of crystal structure of blue vitriol and this water is called as the water of the crystallization. This water is structure of the soil and hence it is known as the water of crystallization. Now what happens when we add water to the white powder of the solution, okay, which was formed, okay, the color of the solution, okay, the again changes. Okay, so on adding water to a white powder, a solution was formed which had same color as the solution of the first test tube. So what is the chemical reaction? How are we going to write this? We are going to write CuSO4 plus CuSO4 5H2O on heating gives CuSO4 plus 5H2O, which is separated. And once the color is lost, after heating, once the color is lost, when you again add the water droplet, the color of the solution changes. It gains the original color, blue color, and this is known as the water of the crystallization. Children, please read the activity given in the textbook. Watch the videos so your concepts will be becoming more clear. Good morning, children. Students, in your science and technology part 1, we are now going to study the concept about ionic compound and electrical conductivity. Children, this activity is mentioned in your textbook also. I am just reading out the activity. Prepare a solution of 1 gram sodium chloride in 50 ml of water. Take 2 electrical wires. Connect one wire to the positive terminal of 6-volt battery while connecting the other wire to the negative terminal of the battery. Include one switch and one holder with an electric bulb. Remove the insulating cladding from 3 cm portion of the other free ends of the 2 wires. Now we have to take the solution in 100 ml capacity beaker and immerse the uncovered ends of the 2 wires in it, keeping the wire erect with the help of a support. So we have to switch on the current. Now just note whether the bulb glows. You have to repeat this procedure using solution of 1 gram of copper sulfate, 1 gram of glucose, 1 gram urea, 5 ml H2SO4 and 5 ml dilute sodium hydroxide, each in 50 ml of water. Then record your observations in a table. Do not forget, there are certain precautions while doing this activity. Do not forget to clean the beaker and uncovered parts of the wire with water each time you change the solution. You'll be able to see, student, that the bulb glows only when the electric current passes through it, and this happens only when the electric circuit is complete. Now regarding electric circuit, you have already studied basic introduction of electric circuit, electricity in your previous chapter, 3rd chapter, current electricity. So children, in the above activity, the circuit is found to be completed when the aqueous solutions of sodium NaCl, CuSO4, H2SO4 and NaOH are used. It means that these solutions are the conductors of electricity. Electrons conduct electricity through electrical wires and ions conduct electricity through a liquid or a solution. Electrons leave the battery at negative terminal, complete the electric circuit and enter the battery at the positive terminal. When there is a liquid or a solution in the circuit, 2 rods, wires or plates are immersed in it. These are called electrodes. Now electrodes are usually made up of a conducting solid. Now the electrodes connected to the negative terminal of the battery means of a connecting wire is called a cathode, and electrode connected to the positive terminal of the body of the battery is called the anode. Now this was introduction regarding the cathode end and the anode end. Children, these electrodes information you can just once again read. For the more information of this, you can read the textbook and once again watch the videos. So at the end you will come to know that the circuit is completed and the bulb glows, but it does not happen if the circuit is not completing. And positive terminal of the battery is called anode and the negative terminal of the battery is called as the cathode. So children, this was regarding the introduction which about the positive terminal and the negative terminal. The remaining we will be continuing into the upcoming videos. Good morning children. Children, now we will be continuing with the concept of dissociation of ions and electrical conductivity. Now as we have seen in the previous video, it was found that the aqueous solutions of compounds of sodium chloride, copper sulfate, H2SO4 and sodium hydroxide are electricity conductors. So this is the diagram of the dissociation of ions. Now out of this, NaCl and copper sulfate are the salts. H2SO4 is strong acid and NaOH is a strong base. Now we have seen that the salts, strong acids and strong bases dissociate almost completely in their aqueous solutions. This you have already studied in the classification of acids, base and alkalis. Therefore, the aqueous solutions of all these three contain large numbers of cations and anions. A characteristic of the liquid state in the mobility of its particle. Due to this mobility, the positively charged cations in the solution are attracted towards the negative electrode or the cathode and move towards the cathode. And on the other hand, the negatively charged electrons, negatively charged anions move in the direction of the anode. The movement of ions in the solution towards the respective electrodes amounts to the conduction of electricity through the solution. From this, we can understand that those liquids or solutions which contain large number of dissociated ions conduct electricity. Now, this was regarding the dissociations of the ion. So now, till now children, you might have understood the concept of the dissociation of the ions, and you will always say that if a positive ion is going to attract towards the negative electrode, and the negative ion is going to be attracted towards the positive electrode. Okay children, so this was, see, this is if you look towards this diagram also, so you will be able to understand, your concept will be becoming more clear children, that how the dissociation of the ions takes place. If you will see the two electrodes are there, the positive terminal of the electrode is has attracted the negative ions and the negative terminal has attracted the positive ions. So this is how the dissociations takes place in the liquid solutions, or how the strong and weak acids are continuing with each other. So sir, children, remaining we will be continuing in the upcoming videos. Please watch the videos, refer the textbook, so that your concepts will become more and more clear, and if possible, once again revise the whole chapter from the beginning. Good morning children. Children, today we will be studying the concept of electrolysis. For this we have to just go through a procedure, we have to go through an activity, so which I will be just already demonstrating you. Take a solution of 1 gram of copper sulfate in 50 ml water in 100 ml capacity beaker. Use a thick plate of copper as anode and a carbon rod as cathode. This diagram is here children. Okay, you can refer it for the future reference, and this is given in your textbook also. So as the I am going towards explanation part, you kindly refer this diagram so you will be able to understand the concept of electrolysis very properly. Arrange the apparatus as shown in the figure and pass an electric current through the circuit for some time. Do you see any changes? In the above activity, copper appears to have deposited on the portion of the cathode immersed in the solution. How did this happen? When an electric current started flowing through the circuit, the cations, that is Cu double plus ions in the solution, got attracted towards the cathode. Cu atoms were formed when electrons coming out of the cathode combined with Cu plus plus ions. A deposit of copper appeared on the cathode, even though a characteristic of the liquid state is in the mobility of its particles. Because while electric current was on, electrons were removed from the copper atoms of the anode and sent to the battery through the electric wire. The Cu plus plus ion in the solution were used up in this manner. The color of the solution remained same. In this way, the decomposition of solute in the solution took place due to the electric current, and children, hence this process is called as the electrolysis. Now children, there are two parts in electrolysis process. There are the cathode reaction and the anode reaction. The two parts of the electrolytic process are as follows. They are shown in the chemical reaction. At cathode, what happens? Cu2 plus plus 2E gives Cus, and in anode reaction, Cu, copper in the solid states, gets dissociated and forms Cu2 plus 2E minus ions. Okay, so these are the two different reactions taking place in the anode and the cathode. Children, here if you look towards the diagram, you will be able to understand. See, the positive electrode has attracted the negative ions and the negative electrode has attracted the positive ion, and this process is known as the process of electrolysis. Electro means electricity, children, and lysis means breaking. Okay, so when any element is broken, when the ions are formed by the breaking due to electrolytic process, that process is known as an electrolytic process or the process of electrolysis. Children, please go through the video and refer the textbook so your concepts will be becoming more clear. Good morning, students. Now children, now we will be focusing towards the study of electrolysis of water. For this also, I will be demonstrating an activity. Dissolve 2 grams of salt in 500 ml pure water. Take 250 ml of this solution in 500 ml capacity of beaker. Connect 2 electrical wires to the positive and negative terminals of a power supply. Remove the insulating cladding from about 2 cm portion at the other ends of the wire. These two are the 2 electrodes. Fill 2 test tubes up to the brim with the prepared dilute salt solution. Invert them on the electrodes without allowing any air to enter. Start electric current under 6 volt potential difference from the power supply. Observe what happens in the test tubes after some time. It is found in the above activity that the volume of gas formed near the cathode is double that of the gas formed near the anode. Scientists have shown that the hydrogen gas is formed near the cathode and oxygen near the anode. From this, it is clear that electrolysis of water has taken place and its constituent elements have been released. The concerned electrode reactions are as follows. So we get at the cathode 2H plus twice H2O plus 2 electrons. We get H2 plus OH minus ions, and anode we get H2, which gives oxygen plus 4 hydrogen and 4 electrons are released. So these are the different reactions which are occurring in the anode and the cathode end. Okay, and this is due to the electrolysis of water. So children, electrolysis of water, we come to know that at the anode you are having oxygen plus hydrogen and 4 electrons are released, and cathode hydrogen plus 2 OH minus ions are released. Children, please go through the textbook, go through the videos, watch the videos twice and thrice, read the textbook so your concepts will become clear accordingly.